Dean and Gavin, welcome. As you guys join us, we are in our notes. Everybody's technically in their workspace waiting for us to grade or go over questions on section 9.5. But we are introducing section 9.6 using this pre-cal review. I don't know, number 5 was this year's special converging sequence. But with the factorials, it's technically pre-cal review. So they were working in groups trying to figure out, do you know what this becomes, and this, and that? Because they're all necessary and important and helpful for today. And wow, I'm talking loud because I'm used to talking loud to you guys on the video. Anyway, thanks for joining us. We're going to go check in and see how they did before we go grade our homework, which has no evens unless I added an even to section 9.4, which is a bummer because that means there are evens. Anyway, let's come on back and let's check in. So you guys out here in the peanut gallery, that's you. What have you thought about? I don't want the answer, because some of you, that's how you explain things. Well, the answer is this. Why is the answer k plus 1? Oh, what were you thinking about for number 1? Factorial rules. What are factorial rules? K times. It gets hard. If you have always defined a factorial to count backwards, as soon as there's a variable, you kind of get lost. If you've always thought about factorial as counting backwards, you're going to get lost as soon as there's a k or an x or a c or something else, because you're like, what's before k? K minus 1. What's before that? K minus 2? K minus 3? How long do you go for? I don't know. Okay, we're going to count up. Now, I know. My definition, what I'm showing you, is assuming that k is something high. But pause and think. If we're talking about sums, series, infinite series, are we going high? Yes. Yeah, n's going to infinity. Oh. Okay, so if we're talking about infinite series, we can start at 1, 2, 3 and we'll be fine, okay? K is going to infinity if it's inside a sigma, an infinite series, which is what we're doing. Now, I could just stop at k. But to get the idea across, couldn't I have k minus 2 and then k minus 1 and then k? So I'm going to have you guys think about, hey, don't we always start from 1? I mean, isn't there always a 1 times a 2 times a 3 in anything that's a large argument of a factorial? I think I can say argument of a factorial. So this one starts off with 1, 2, 3, but what could this one start off with? Could it also have a k? Well, I mean, if it's going up to k, it's going to have all of this, except what else is it going to have? Okay. I'm counting up instead of down with factorials. Yeah, I'm counting up to the highest instead of down. Wait, what? No, every factorial always goes all the way down to 1. So they can both have a 1. So it's 1 more. So if k was 10, 8, 9, 10, 8, 9, 10, 11. Oh, that's smart. Oh, but Iris, what I'm trying to show you is eventually we're going to infinity if this is. Sorry. And so I'm talking about for large values of k. Yeah, I'm talking about for large values of k. Because of the reason, okay, when you plug in 1, just 1 and 2. But, I mean, you would end here, right? And this would end 1 before. Does that make sense? Because even if it was 1 factorial and then 2 factorial, well, I still have 1 times 2 and 1. This is always 1 more. Does that make sense? Yeah, I know it's a little confusing with the variables, and I'm trying to say we're going to infinity, so for large values of k. What's always going to happen in something like this, where I have an n factorial, n plus 1 factorial, is he's 1 beyond, that's all that's left. Everything else is simplified. Now, when we go down here, I don't need to write as much, do I? Wouldn't this just be 2n? So if n is 10, I'm going up to 20. And I'm going up to 22. How does that work? Well, wouldn't this go up to 2n? What would be the next term? 2n plus 1, because factorials always only go up by 1s if I'm going the opposite direction, right? How factorials are defined. So this one, the answer isn't 2n plus 2. The answer instead is 2n plus 1 times 2n plus 2. Does it make sense? If I was go by 1? Fine.
Is this finding what it converges to?
No, this is strictly factorials with variables. In pre-cal, we've talked about them. I'm saying this is going to be used in sigmas in a second. So when Yaris was like, well, what if that's just a 1 and that's a 2? There's no 2 in there. I'm like, okay, but we're going to sigmas where we're going to infinity, so we can think of big numbers that are in here. But technically, this is just pre-cal where you guys actually had x's, not probably n's or k's, but x's, and we actually talked about simplifying factorials with numbers, but also with variables. So far, still review, but this is a hint that I think we're getting into some convergence tests that might help us with factorials if they show up. Now, here's one more. I wrote the one, technically the one's not really supposed to be there. I suppose it's just the n root of n. I wrote the one to be like, hey, it's n to the 1 over n to the 1 over n. What's the limit as n goes to infinity? You could have memorized your special converging sequence. You could also be thinking of what's going on when I plug in and whether or not it's indeterminate. Good question. What is that limit? Infinity to 0 is 1? Is that what the special converging sequence was? Is infinity to the 0 indeterminate or determinate? Is infinity to the 0 indeterminate or determinate? Because some of you guys are like, yeah, duh. I mean, John and Ryan are just goofing off. But the rest of you guys are hopefully trying to pay attention. And when you do pay attention, boys, that was a warning. When you do pay attention, I mean, are you thinking infinity to the 1 over infinity? Well, 1 over infinity is going to 0. Infinity to 0, I sure hope it's not indeterminate. So I'll just say it's not indeterminate. And the answer, anything to the 0 power, is 1. But for that, aren't there other ones where that does not hold to be true, right? There are some things in your head that do not hold to be true. Now, technically, according to this, is the limit 1? Yes. Can I think of infinity to the 0 being 1? Yes. But are there other things that I could have made sense in your head that are wrong? Yes. This is 1, but this is indeterminate? I don't get it. Like, anything to the 0 power is 1, and 0 to any power is 0, right? You see what I'm saying? I'm warning. You can't always just be like, yeah, duh. You need to know, no. This is on the special converging sequences. Like, yeah, I can think of infinity to the 0 as 1. You need to realize that's legal, and you need to know this is indeterminate. L'Hopital's, and we talked about the indeterminate forms. You guys see what I'm saying? You need to be careful. What do I mean? Well, I mean, this one, I've starred 2 of them on here. Maybe I should have started that one too for the root test. Ooh, root test. The other one's the ratio test. This one, if I go to infinity, isn't that 1 plus infinity always wins whatever's up top? So 1 plus 0 to the infinity. What's 1 to the infinity? 1, of course. No, it's not. It's e to whatever's on top. Like, not all of these are like, oh, my head says this, so it's right. You gotta be careful, yeah? You guys see why I'm slowing down and why I'm trying to be like, sometimes what your head would say is indeterminate, so you gotta be careful, because that's e, that's not 1. This is 1, it's good.
That's a little bit off topic, but
Why?
I explained where does that formula come from.
Oh, we already talked about that formula then.
I mean,
When we were doing L'Hopital's?
Original, like, where does that formula come from?
Oh, you want to wonder.
I know.
No, it's great. Yeah, I took a workshop on it when I went to my math conference. Can you do it in like 30 seconds or less?
Yeah, it's basically like the interest rate in the bank. So if x equals to 1, and you're doing like...
It's like 100%.
Yeah. So if x equals to 1, the final will be e. So it's like the maximum amount you can get by investing money into a bank. Like no matter how many months.
In thinking of compounding interest, which is compounded not continuously, but at different increments throughout the year. And what Lorenzo is referring to is that old school pre-cal. Wow, pre-cal. Hi, welcome to CalcBC today. Because back in pre-cal, didn't we talk about not only PERT, which is continuously, just kidding, PERT, right? But the RT was up here. But also another one that had to do with 1 plus, oh my goodness, the rate with how many times a year it's compounded, all raised to the NT.
Wait, so why isn't 1 to the infinity 1?
Because technically we did L'Hopital's to that limit way back when, and the only way to solve that limit, like if we were, because I mean, to some degree, you guys are memorizing this because we put it in our special conversion sequences. Otherwise, we'd have to be doing L'Hopital's right now and not just jumping to one. That's very dangerous. What we just did. This one though, we went ahead and took this n power. We took ln of both sides. We brought down the n. We then were able to go ahead and make it division by 1 over n to do L'Hopital's, I believe getting 0 over 0. We went ahead and solved that limit and got that limit to be 1. But the problem was it was ln of the original limit equals 1. We had to do e to both sides. And that's if there's a 1 on top. If it's a 2, the limit would have been 2 e to the 2. If it was a 10, it'd be 10 e to the 10. That's after doing a proper L'Hopital's analysis. So all of that means, well, wait a minute, if L'Hopital's is telling us it's always e to the power of, then hold on, our brain picking 1 to the infinity, we can't make the jump and say it's 1. Think of it this way, it's not truly the number 1 being raised to the second, third, fourth, 10th, 100th, a millionth power. It's a quantity that is converging to, or I should say approaching 1, being raised to approaching infinity powers. So it's not truly 1 to the infinity. Our brain is just trying to think about 1 to the infinity to answer. Does that make sense? So then in similar ways, this one, we could go ahead and do a L'Hopital analysis. We could take ln of both sides, and I don't think we've actually solved this one. For the L'Hopital analysis, you would have the ln on the other side. What would end up happening if you bring down the 1 over n, you have the ln, you put it in the denominator. Your limit, oh, we've done one similar. The limit would be, let me do it fast, sorry. ln of, this is what we're trying to solve. Over here, we would have 1 over n, ln of n. Nice thing is this, we can just go ahead and put there. We have infinity over the infinity, so we can use L'Hopital's, which is going to end up being 1 over n, over 1, sorry. Instead of getting a constant for our limit from L'Hopital's like we do in the second start or the first start one over there, we end up with a 0, but we have an ln similar to what we would have over there, but this time instead of e to an actual constant, we have e to the, I shouldn't not call 0 a constant, a non-zero constant. We have e to the 0, which ends up being 1. So technically we should probably have a defense behind everything we do. However, in getting ready for root tests, it'll be helpful just to have this one memorized. And to some extent, you should have the E one memorized too, or you could solve it every single time. But a lot of you are going to accidentally just go with, well, it makes sense in my head. And more infinite series, hopefully, are making you at least somewhat second guess your own rational thought, in the sense of like, wait, I understand that. I can always make these huge jumps. Well, with things that you're unfamiliar with, especially with limits that we haven't truly solved, limits with the definition, the epsilon delta definition of limits. A lot of the ways that we solve limits are the tips and tricks that have worked for the level of problems that we've seen. But when it gets to indeterminate forms, we have a gap in our understanding because we didn't do it the long, harder way. But if we had been doing it the long, harder way, we would see these gaps a little bit more clearly. But for the AP test, I mean, sad but true, I need you to be able to go fast, which is why the tips and tricks were enough. So that's also why a college professor would be mad at me. Like, you didn't teach that much on delta proofs. Well, I told you guys the other day. I showed it to you that you could go learn. I didn't use it. But I need you to have these forever endeavors done. Yeah? Or always have in the back of your mind, my brain is saying this, but do I have a reason why? Oh my goodness. Life lesson. An extreme one that our culture, your generation, needs. To be honest, so does mine, but so do the ones above us. Both. Just because we are fully convinced of something doesn't make it right. Do you have a defense? Oh, there's a Do you have a defense as to what you think and why? And from a Christian perspective, who are you putting at the center of your truth? You? You and others? You and others and God? If it's just you, it's going to be in balance. If it's just others, it's going to be in balance. If it's just God with no consideration of yourself or others, it's going to be in balance. Which is why when Jesus was asked, what is the greatest commandment? He didn't just say, love God. Because if you just love God, who are you going to naturally probably forget about? Maybe yourself. Definitely others. Most of us don't truly forget about ourselves. Even those with self-harm tendencies, you're not truly forgetting about yourself because you're still focused on your own personal pain more than your worth or your contribution or your possible contribution to others. That's a really hard truth, though, and so I'm not going to go into that anymore, but I'm more than willing to talk it through with anyone who doesn't understand that statement. Anyway, that was like, whew! Haven't done a good life lesson. And to be honest, I love in CalcBC Convergence and Divergence of Infinite series because why does 1 over n diverge and 1 over n squared not? Why does 1 over n to the 1 diverge and 1 over n to the 100 over 99 converge? Like, how does that make sense? Both terms are converging to 0. How does it make sense? You have to have a way. You have to have a way to test. And from a Christian perspective, our way is exactly what Mrs. Ranieri said. Noelani was definitely answering, but then Mrs. Ranieri said, what is my number one way to tell whether it's the Spirit or whether it's me? She always goes back to, is it Scripture? Does it contradict the Bible? If it contradicts the Bible, now yes, there's culture and it's, we talked to Mr. Carmichael, the whole like, your neck is like the Tower of David. Like, it wasn't the Tower of David, it's a neck. But anyway, we talked to Mr. Carmichael about figurative language in the Bible and some things that shouldn't be taken literally. He is by far a much better authority than me. But ratio of the test, you guys are hopefully multitasking and writing it down because it's in a yellow box and it's going to be important for today. And do you guys see something down here that talks about factorials or nth powers? Wait, nth powers! Oh, we love those. Those are geometric series. Sometimes, unless there's like a plus with the nth power or a minus with the nth power. Oh, we have a new test though. It's okay. And guess what? We are finally at the end of part C. P series, we've done that. Altering series, we've done that. Telescoping, we've done that. Integral, we've done that. Nth term, we've done that. Geoseries, we've done that. Direct and limit comparisons, we've done that. Where are we at? Ratio, root. And then like Moses parting the Red Sea. Oh, just kidding. God doing it through Moses. He was just available and obedient. But either way, we're at the RR. Those are all the convergence tests. Parting sea. I don't know if it's the order per se, but it's a way of remembering. And so if you ever forget or you run out of options, go through PARRTINGCC and figure out one that you can or haven't tried yet. You're here. You're in your notes. Most of you, you're taking this. Can we just camp out here for a second and talk about the test before we go talk about 9.5 and whether it was good or bad? The test as in the ratio root test, as in like the test for convergence or divergence. You can read the board about the rest. The tests. The test for chapter 9. The tests. You need to finish. Shh, focus.
Wait, we have so many tests.
Oh dear. Lost you. Yes, there's an endeavor fill in the blank on Thursday of all the endeavors from this chapter, culminating in. There's one more. There's one more after this. But basically culminating in the ratio root test. Including the estimation theorem and absolute versus conditional and a couple extra ones, not just the test, but the test for the majority of the fill in the blank. It's a full sheet with like little blanks, literally like forever cards with blanks. You just have to fill it in. So it's not going to be a you state the whole card. You just need to know each of the conditions and conclusions of each card. Does that make sense? It's supposed to be nicer. It's definitely supposed to be nicer and take off the pressure of like a state IBT. It's supposed to take off that. However, there's also a part 1 on Thursday. There are some practice tests. There's a test review, and then there's a practice test. I think I actually may have 2 different practice tests. We'll talk about that more tomorrow. I just want to get through this last ratio root thing today. But you're going to have lots of practice problems with answer keys from me and my work shown. The more you practice, the easier it'll be. You guys will also get back your chapter 9 quiz from just the first 3 tests, because you were like, oh, those were the easy ones. Yes, but your justifications need help. But the nice thing is, those of you that got like below 10 out of 20s, which was probably a third to a half of the class, listen, I'm motivating. We did have a 19.5 out of 20, David. Excellent job. The next gap, I think, was somewhere in the 17s, David Park. The next ones were like in the 17, 16. Those were still my highest scores, and then it just... come back. Your chapter 9. Chapter for everyone. But she got in the 16, 17 range, somewhere in there. Come back. Listen. Some of you underestimated it. This test can replace that quiz score. It'll count for itself, but if the test is higher, I'll replace it. I'll bump it like the whole end of the semester final exam. Sound good? Because if you can show me that you know the whole chapter, like, all right, but you need to study that quiz and be like, what did I not do? I didn't put down any test that proved anything that I was saying. Oh, well, awkward. Coming back. Hey guys, do you see some limits? Do you see limits of something over something? Oh, we've done that. The limit comparison test. Yeah, but that one was a sequence over a whole brand new but similar sequence. Remember, it was an A sub n with a B sub n. We went and chose somebody out of thin air. Not really. We were very strategic, but we chose somebody to make that comparison with, right? This time, we're doing a sequence with one higher. We're doing an nth term with one higher. Oh, n plus 1, k plus 1. Oh my goodness, it's like what we just did. We're taking a comparison. Let's take away the word comparison. We're taking a ratio of an nth term with its n plus first term and comparing it. So we don't even have to go out there and go searching for something to use. We get to actually use itself, just one higher. And then the root test is we're taking an nth term and we're saying, ew, you have lots of n powers. Let's just take an nth root of you. Let's take an nth root of you. Now, what's a little bit complicated are these. Because unlike some of the other tests, you have 3 different things to keep track of. Either a limit is less than 1. What's less than 1? Positive little baby numbers, 0, and negative numbers, right? Okay. If the limit is less than 1, the series converges. Any of those? Wait. If I have positive terms, should I be getting negative numbers? No. Okay. Anything less than 1, the series converges. Anything greater than 1, the series diverges. Okay. Could this get a little confusing with the nth term test, where I have equal to 0, not equal to 0, it's bigger than 0 then, and this one's bigger than 1. Could this also get confusing with P series, where I have P is greater than less than 1? You got to be careful and get all these facts straight, hence the endeavor quiz. But then what's the struggle? If the limit equals 1, it's great for the limit comparison test. It's awful for the ratio root test. there's another we know nothing and we have to go to another test. Or we have to, oh wait, we weren't picking things here. We don't have an option. If the limit equals 1, these tests fail and I have to move on to something else. Factorials, yes, ratio. Specifically, ratio. Factorials, we want to think ratio. And then nth powers, we want to think root. But the nice thing is, whether you have ratios, or whether you have factorials, or whether you have roots, the conclusions are the same. This is the last one where the limit tells us something. Well, usually something. Usually something. This one, this test could sometimes possibly tell us nothing. And yes, some of you on the quiz said the limit equals 0, so it converges. That was before we learned alternating. They weren't alternating, and you used the nth term test completely wrong. Anyways, we're moving on. You'll see it. You'll study from it. It'll be all right. Remember, the test. The test. We'll do better, and we'll cover. Okay. Love y'all. Don't worry. This is nothing that's unique to your class. Every year the quiz is run for some.
For some.
For some. I just said it. I just said it. Some of you rocked it. There are others of you that got in the 16, 17 range, and David. But. Oh my God. I don't remember who else. He just said the top scores. So. Okay. So guys, Geo, it's not. Nth term, we know nothing. We know nothing. We know nothing. Alternating, it's not. Oh, should I be going through things? P series, it's not a 1 over n to the p. A lot of you use the p series wrong. That's the first actually. P series, it's not. Alternating, it's not. RR will come back to. Telescoping, it's not. Integral test, we don't know how to integrate factorial. Exactly, it's not. Nth term, it fails because we know nothing. Geometric, it's not. And the comparison test, what would you even compare factorial to? Like, it beats everything. Okay, actually, you could do comparison test. But, how does the ratio test work? Well, I mean, I just said you could do a limit comparison test, because couldn't we compare it to 1 over n squared? Converges p series, p is greater than 1. And then I would go ahead and multiply this by n squared over 1, because remember the limit comparison test. And then what's the limit? If this says always stronger, 0. 0 says converging, I know converging. Okay, by limit comparison test, we know converging. If we were to take time and flesh it out, right? So let's see what the ratio test does, and whether we like it any better. Ratio test would say, take a limit, as n goes to infinity, positive terms only, it does, of the n plus first over the n. Hey, you see why I was having you do what I had you do at the beginning of class? Isn't this going to end up being, and maybe some of you will start to realize this, just n factorial over n plus 1 factorial? Some of you still are stopping writing your limits. You gotta have proper notation. Write that limit. Doesn't this end up being? The factorials are gone! Of course they are, because 1 over n, or 1 to n, reduces with his 1 to n, only n plus 1 is 1. What's the limit? 0. What's 0? Less than 1. What does less than 1 tell you in your test? It converges. Wait, if one converges the other? No. I'm not comparing it to something else. Just converges. Oh. Then. Bye. Ratio test. Series. Converges. Dun, 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 dun. P.S. It's not sigma of. Sigma is 0. It's limit of is 0. Just fine-tune some of the information. What about this guy? What about this guy? Yes, limit comparison, convergent. Ratio test, convergent. This guy, I had to think of someone and hope that it was 0 to show converging. This one, just go with the n plus first over the n, and then, no, there we go, converging. This one. Nth term, bottom line 0, we know nothing. Geo, it has an n on top, not just a fails. P series, it's not. Integral test, hope not. Comparison test, what do I compare it to? Okay. What else could we do? Is this an nth power that I don't like with Geo? Yes. Some of you guys on the quiz had to use an integral test with a 2 to the negative x and you didn't like it. I understand. We had this new thing called a root test, so how does that work? The limit as n goes to infinity, positive terms, check. I should probably show that. Close the end, so positive terms, check for all n, so we're good. For all n greater than or equal to 1. It says take the nth root. So if you like, you could totally show it like this. Or you could think of it as I think how the card shows it, to the 1 over nth power, if that makes it any better for you. But if I'm taking the nth root of n, or n to the 1 over n, oh my goodness, that's what we just talked about. It's right there. And then if I'm talking about the nth root of 2 to the n, or if you like it as 2 to the n over n, what happens if I do 2 to the n over n? That's just 1. Like, it's 1. Like, it equals 1, not approaching 1. It is 1. So therefore, all I have is 1/2, which is less than 1. What do I know by the ratio, or by the root test? Yeah, series converges. You can do your limits, and as long as it's not 1, not too bad. If you have an nth power you don't like, use the ratio test. Or root test, sorry. If you have factorials, just use the ratio test. Does it work for other things? Yes. What if you have both? What if you have both? What sounds better? The n plus first of something to the n, or the root of a factorial? So we're going to have to either do the nth root of a non-nth power, or an n plus first of a non-factorial. Which one sounds better to you? Just go with one. I'm just curious what you're going to come up with. Sounds better or worse?
Better.
Yeah. The nth root of a factorial. Remember how a second ago we don't know how to do integrals of factorials? I'm not sure we know how to do nth roots of factorials. Definitely not up there on that card. And I'm pretty sure I don't want to do L'Hopital's taking a derivative of a factorial that I can't derive. Let's stay away from roots if we have a factorial. Factorials always point us to ratio test. So if you do limit, as n goes to infinity, are you guys realizing yet that we're going to be doing our n plus first times the reciprocal of the n? Have we gotten that down yet? Have you seen that yet? It's dividing by the n, so you're always going to be multiplying by the reciprocal. It saves you a little bit of work and it makes it look not quite so confusing. You could even put that technically in your test if you want. A to the n plus 1 times 1 over, or reciprocal of a to the n. We need to simplify. Do you guys see something that we like? Hopefully. But do you also see something that you might not like so much? Name of the game is simplify. Name of the game is not just thinking something is true, but knowing it is true. I know in life, I made it sound maybe a little bit simple earlier. There are still some gray areas, for sure. But a lot of us want to think some things are gray areas, but truly they're not. If we know and love the Lord and care about His perspective. But coming back, do you see that guy can become 1 over n plus 1? So what do we do with the other guy? Could we do that? Look, it goes away. But do you know what that other thing is? Oh yeah, of course, the degrees are timed, so it's just 1. One, the test fails. The answer is truly E. E is greater than 1, which means by the test it diverges. Why is it E? What happens if you put n plus 1 all over n to the n? Is he still hiding from you, or are you starting to find him where he occurs? logic is saying, or are you realizing there are some things beyond what you are naturally understanding right now? 5. Ratio test. Anything greater than 1? But would you have been tricked and thought the test failed and then been totally stuck with no path forward? What did we not do? Go over questions in 9.5. What's going on with 9.5? Hopefully you calc chatted it and you're coming to me with informed questions, not just I don't like it questions. True? Alright, tomorrow we'll go over alternating series questions first. Then, no, I haven't written them down in the grade book. Sorry, and TAs can't because it's BC. But you can by 7th grade. I can show you. Sure, as long as someone from student